So we've added some upfront security to our proxies, and we want to protect our proxies from malicious users. Security alone sometimes will not be enough to protect yourself from attacks like DDoS or some other malicious attacks, SQL injection and such. So we have a few policies that allow you to protect your APIs at a fine-grained level using regular expressions or specific policies that actually work directly with the payload types that you're using. The first one that we're going to cover is the regular expression protection policy. This is kind of what I call the Swiss Army knife protection policy. It allows you to set up protection from several different forms of attacks. For example, a SQL injection attack. If you look at this slide, we have a sample of 5 or 6 different attacks that can be prevented using regular expressions. What's great is because it uses regular expressions, it can be modified over time to prevent new attacks that surface fairly easily. Do note that when you're adding this policy that the regular expression needs to be URL encoded before adding it to the policy. Here is an example of a regular expression policy being used. Now, the regular expression policy, protection policy, will use a similar format as the extract variables to get to what you're wanting to test. In this case, we're testing the body of the request, and we're testing it for the scenario that it is a JSON payload. The way that it determines that it's a JSON payload is based off the content type. So if you don't have the content type set to application JSON, it will not check this particular threat. A way of getting around that is to modify the content type in your application flow and then preserving the older content type in another variable. Here's another example of using the regular expression policy using query parameters. You can see that the name of the query parameter it's evaluating is called test me, and the patterns that it's looking for are some pattern and some other pattern. So if either one of those patterns were in the URI in that query parameter, you would be able to validate that it tested negatively. The second threat protection policy that we'll look at is the JSON payload protection policy. And what the JSON payload protection policy does is it minimizes your risk posed by content level attacks using JSON. Some of the key elements that it looks at are array counts, container depths, object entries, and the length of your strings. This can also be used to validate that your developers and your developer apps aren't using your API in a way that you do not want it to be used. You can put restrictions on the data that's being passed in and passed out of your API in this form too, beyond just the threat protection policy. But the idea is that there are JSON attacks that can be created by passing very large JSON structures, and what this does is it preemptively stops those requests from getting to your backend and causing issues with your JSON parsers. Conversely, with XML, you have the XML payload protection policy, and it works almost the exact same way. It works in a way that it's looking at the depth, your attributes, your namespaces, your elements, and it's just making sure that the right number of those elements exist, and someone is not trying to attack your backend by adding multiple attributes or recursive attributes into your XML. And those are our threat protection policies.